say something about his area, which is integrated language technologies, speech and language technologies, the next generation localization CSET.
Thank you very much. I thought initially I was going to be speaking for about 5 minutes, and then Ryan had asked me to speak for 25 minutes, and now I'm going to speak for about 15 minutes. So you have to be adapted in this sort of environment. Things change very quickly. Okay, so a quick overview of the presentation. I'll just talk about the role of the IoT component in the CSET. You've heard a lot of this already. Many of the same slides I'll be presenting that you've seen already on yours as always. Different ones than the ones that Vinny showed though. What we're essentially about is facilitating optimal multilingual next-generation localization applications, and I'll give you an overview of those as we go through. I'll talk about the key research challenges for machine translation for speech mostly, but also for the textual analytics component. Give you a quick overview of some of the novel research aspects that we aim to cover. And then before talking about the key integration challenges, I'll just do that with reference to what you all understand to be the traditional sort of kind of localization workflow that you all use, and then I'll conclude very rapidly. So this is the kind of localization factory that you've seen before, and just to remind you, so we are one of the horizontal research tracks along with DCM. So you'll see this little picture at the top right-hand screen of each of the slides, so that you can, if you kind of nod off, you'll remember which of us is speaking about what, because I realise that we're kind of monopolising this morning's session. But essentially we have two input modalities in the CSET, text and speech. Okay, so of course these are the three components there along the middle of the slide. So text processing and as you said, very central to this component. It plays a major role in some of the in the three scenarios that again those of both Vinny have spoken about. But speech also, and I'm going to give sort of a few slides on speech. But that's being looked after by Julie Banser, mostly in UCD. I don't need to convince you, I don't think that MT is a significant or has the potential to be a significant player in the localization business. Joseph talked about the three aspects to what we're about, and clearly here we're talking about the volume situation where there's so much stuff out there to translate. We're only sort of prickling the surface of what could be done, and certainly in the online on-demand translation scenarios that we envisage, then automation is the only option. There's not enough time in the process to actually integrate humans into the loop. Okay, we can't do pre-editing, we can't do personal editing. We want translation on demand, so it has to be automated. So research challenges for MT essentially are improving the quality. Okay, so the quality is improving all the time, but it's still less than what might be desired by most users. Okay, so that's an ever. So we're always aspiring to improve the quality of the systems that we produce them faster as well, and deal with scalability, and that's a double-edged sword. So we want to scale up to the bulk scenario that many of our sort of large industrial partners play a role in, but also scale things down. Okay, so when we're talking about accessing information on small handheld devices, of course we can't have our sort of main machine translation systems trained on millions and millions of sentences, millions and millions of words playing a role here, because it's just far too big to be accessed in any sort of real-time situation. And of course dealing with other modalities such as speech. So just a quick overview, a non-technical overview if you like. So the state of the art, as I've just said, is improving, but it's still not perfect. And today's corpus-based MT systems have a tendency to omit verbs. Okay, so SMT systems have a tendency to omit verbs. And the reason is, as people have alluded to before, even for a morphologically impoverished language like English, a typical verbal form is not seen very often. Okay, so the statistical systems of today base their decisions on prior observations of linguistic content. If they haven't seen a particular three-word sequence before, then it tends to disallow that as a legitimate translation. So typically, here's an Arabic sentence. You can see what the reference, the gold standard translation is. But the system, a typical corpus-based system just omits the verb. Okay. Now, we can improve on the state of the art. Our system in DCU has knowledge of syntax, it has knowledge of parts of speech, and it has knowledge of the roles that the words play in the sentence, and can improve the translation quality. So for this particular sentence, you can see the output that our system produced. Okay, it's not the same as the reference translation, but a much better translation than the baseline. Here's another example where the baseline system omitted the word not. Okay, now the word not is quite an important word in a sentence. It really changes the truth value of the sentence. And again, you can see that the baseline system chose to omit that word not, but our system actually outputs it. So we can produce better translation quality, especially where the end users are concerned. So our system so our Arabic English system was ranked first at an international evaluation last year by end users, okay? Not according to the automatic evaluation metrics that you may have heard. Okay? So again, you can see here that so our system has produced a pretty good translation, but it's different enough from the baseline, different enough from the reference translation that the improvement doesn't carry over according to the automatic evaluation metrics. Okay, what we plan to do as a major component in the C set is to take the documentation of our industrial partners and train up different types of MT system for different types of text and genre. So we'll produce a multiplicity of different translation systems for different language pairs, for different vendors, for different scenarios. So on the multilingual sort of text processing side, well, hopefully, I've shown you that if text can be automatically annotated with syntactic information, and text type and genre information, and also localization information, then we can improve the translation quality. So, for example, here, you don't want to, if my name appears in the document, you don't want to translate my surname, because you'll get all sorts of weird and wonderful translations in the output. So we just need to be able to deal with, markup, tags, telling us not to translate certain things. That's exactly what you want in your localization workflows. So these are some slides from Julie, and I just noticed that prior to coming up, because I gave Carl this this morning, and you can see that Julie's interested in speech and not so interested in text, because there's a typo there in the first line. But again, on this slide, the three criteria that Joseph emphasized this morning, access, volume, and personalization, all feature strongly in the speech technology work package. Okay, but I think a novel aspect here is that we want to tightly integrate what's been done in speech with what we do in machine translation. That hasn't really been done before, to the extent that we're trying to come up with this integration. So most of the time in the MT world, we deal with text. Okay, but of course, there are a number of extra dimensions involved in dealing with spoken language input. For example, so here you can see, so text usually is nicely segmented. We know what a word is. There's white space surrounding the words, particularly for the European languages. More of a problem for languages like Chinese and Japanese. But again, speech here it comes as a whole stream, unsegmented. So then one of the tasks is to take that input speech and perhaps try to tokenize it as best we could. And you can see that here are two possible segmentations, one of which we'll reject pretty quickly. The second one there, the one below the top one. But the first one, you can see they're pretty much all English words, okay, but it doesn't make any sense, okay. Now, of course, we as hearers of the language, okay, don't have any problem with this. The more it snows, the more it goes. There are no spaces there between the words, but you all understood what I just said, okay. And this is a huge problem for speech that we don't usually face when we're dealing with text in translation. Okay. Now, of course, we're not just dealing with the way that I say it, okay, but these are Julie's slides. So Julie's a dog, and this is what your typical dog might say. Okay, I'm not going to attempt to pronounce that, but Ds rather than THs. Okay, so we have to be able to deal with that. These two things, okay, say exactly the same thing. Okay, so if we had a duck up here saying "Demora snows, Demora goes," you'd understand that exactly. You know, these two inputs are, you know, have the same realization. Okay? So obviously, what Julie wants to do is to actually, you know, model the performance of native speakers, to come up with rules and vocabulary in the system, and try to model as closely as possible the linguistic competence of the native speaker. Okay, so to actually, you know, get the machine to act as closely as possible to the native speaker, or even the non-native speaker. You know, again, you know, most of you in the room perhaps are non-native speakers of English, but you still understood what I was saying. Okay, so speech recognition systems which integrate explicit linguistic knowledge is a major focus, but also, you know, tightly coupling these with MT. Of course, we want to deal with multilingual variants of the same input. Okay, so we don't just want to deal with English here. We want to deal with spoken language translation as a task. Okay, so speech recognition is one particular aspect, but Julie's also interested in speech synthesis. So if speech is our output modality, then of course we need to be able to build speech synthesis engines which can actually output the information, particularly in a personalized situation, personalized localization scenarios. If you prefer the output to be spoken, then we have to build speech synthesis systems. But again, these will be tightly coupled with the MT engine. So we want to avail of information which is typically used in MT in speech, and information which is typically used in speech in MT. That hasn't been done before, and that's something that we want to try and do. Okay, I'll fly through this because this is something you all deal with on a day-to-day basis. Okay, so typically in any localization situation, the documents come in, they're planned through a translation memory, we get a bunch of partially translated documents, each with a confidence rating, and then the next stage in the process is to give these partially translated segments to translators to be translated, and then to be post-edited. And of course, you're all driven by the match score, okay? And that's typically not something that we researchers actually use as a level of evaluation, okay? But of course, it's what you all understand, okay? So we know that, and it drives your business model, okay? So, you know, so translators get paid more, you know, depending on the level of the fuzzy match, or paid less, as I should say. So of course then, you know, the documents are validated and finalized, as people have already said this morning. But I'm not naive enough to think that even if we can show our industrial partners that MT and speech can play a real role for them, that they're going to overnight change their workflow, okay, that has been tried and tested over a number of years. Okay, so if MT is to be successful, we need to kind of seamlessly integrate it into the workflows that these companies have developed over a number of years. Now, there is a particular work package in the localization research track on workflows, and Reinhard will talk to you more about that if you're interested. So again, you know, our aim is to slot this seamlessly into current workflows, or if new workflows are developed during the lifetime of the project, we hope to seamlessly integrate with those as well. So our integration challenges, I came across a paper recently. It's a nice paper which uses MT and TM at the same time. And rather than this be a kind of a pipeline, okay, so only use MT if your fuzzy match is less than X%, 70% or whatever, okay. This is a nice paper which actually uses MT to improve the percentage match sequence, okay. So it actually moves, or it shows some success in moving matches from one class to the next. So actually, you know, cuts cost. I think that's a nice way of integrating the two scenarios. Okay, as I've just said, you know, so Vinny's already said that, you know, we researchers don't speak the same language. You know, MT developers, MT researchers don't speak the same language as you localization users. Okay, so you talk about post-editing costs, we talk about the blue score. Okay? And these two things are chalk and cheese, and there's no mutual understanding of these things. But what would be great is if we could come up with a direct sort of link between the scores that we use and the post-editing scores that you understand. So that would be a nice aim. And also, evaluation is a core theme in our project. Again, it's important to ensure that any MT omissions are highlighted to the end user. Okay? So, if the system just decides not to output something, well, you'd imagine that outputting, the source language words would at least indicate to the post-editor, the translator, that this needs to be translated, rather than just ignoring it, as in the example that I showed you. We want to strongly enforce customer terminology. At least two of the talks this morning are focused on that. And that's not entirely true, as people have pointed out. Dealing with markup and tags will be departure for us, a novel departure, but it's something that we have some good ideas about. Producing true case translations, again, that's important for end users, as we heard this morning. Okay, but of course, doing all this has to be done while taking account of the pre-existing workflows that we all have, that our industrial partners have. So just to conclude very quickly, I don't know how I've done that, not too bad. So for IoT, our wrap-up is almost complete. So we've added 30 new researchers in the areas of text processing, machine translation, and speech processing. So that's a huge addition over and above the members which were already there. So we've got very large teams on any kind of global scale now in these three areas. There's huge interest from our industrial partners, both the large ones, the IBMs, the semantics, and some of our smaller ones, which is great. We'll take input from localization, DCM, and systems framework, as you've heard already this morning. We are playing a significant role in all three of the CNGL demonstrators. Machine translation plays a central role in all three, speech in two of them. And I think what we're about is taking the research tools that we already have, which are significant on a global research scale, and integrating them into kind of the industrial prototypes. And that's our kind of lowest aim, I think, in the project over the next 4 or 5 years, to actually convince our industrial partners that the research, the kind of leading research that we've come up with really can play a useful role in industrial workflows. And as I say, going beyond just translation memories. Okay, thank you very much.
Okay, the heads please, I think. Thank you very much for a very interesting presentation. And we can maybe take one short question as our next presenters are setting up, if there is one. Otherwise, we